So hey guys, today let us see the PYQs for the chapter Electrostatic Potential and Capacitance. Coming to the first question, name the physical quantity whose SI unit is joule per coulomb. Is it a scalar or vector quantity? So the answer is electric potential and it is a scalar quantity. We know that V is going to be electric potential, which is going to be equal to W by Q, where the SI units of W and Q respectively are joule and coulomb. Hence the answer is electric potential. Coming to the second question, why is the electrostatic potential inside a charged conducting shell constant throughout the volume of the conductor? We assume this to be the shell. So let us start writing the answer. We are given that V is constant. Hence, we should know that electric field is going to be 0 and hence there is going to be no tangential component on the surface of the conductor. Okay, there will be no tangential component and hence the work done in moving the charges inside the conductor or on the surface is going to be 0. Hence, electrostatic potential is always constant throughout the volume of the conductor. Coming to the third question, what is the amount of work done in moving a point charge Q around a circular arc of radius r at the center of which another point charge Q is located? So this is the arc containing the charges A and B, where we have drawn the rest of the circle. Okay. So from this figure, we can see that since both A and B lie on the surface, their potentials are going to be same. So let us start writing that VA is going to be VB, that is their potentials are going to be equal to KQ by O. Okay. Now we have to find the work done, which is normally written as W is equal to QV. But in this case, we are going to write W is equal to Q times VB minus VA. Since they both are equal, it is going to be 0. The work done is 0. Okay. Moving on to the next question. Why do the equipotential surfaces due to a uniform electric field not intersect each other? Because if they intersect each other, there will be two values of potentials, which is not possible at all. That's the answer, and we are done with this question. So moving on to the fifth question. Why is there no work done in moving a charge from one point to another on an equipotential surface? Because the potential difference between any 2 points on this equipotential surface are going to be 0. Okay, so we can write it as, suppose we have to write, we can assume it as V2 minus V1, which is equal to W by Q. They are going to be 0. And hence W is also going to be 0 and therefore there is no work done. That's the answer. Moving on. Show that the equipotential surfaces are close together in the regions of strong field and far apart in the regions of weak field. Draw equipotential surface for an electric dipole. So I've already given this diagram, which is the equipotential surface for an electric dipole, but you have to draw this. So guys, we know that, let us start writing this answer. So E is equal to minus dV by dr, okay, where E is the negative potential gradient, okay, and whenever there is going to be a change in dV, E is going to be inversely proportional to dr, okay, that is proportional to 1 by dr. Where a dr is going to represent the distance between the electropotential surfaces. So that's how we can show we have to basically use this formula and draw this diagram, and that's how it is written. Moving on, a point charge plus Q is placed at a point O as shown in the figure. Is the potential difference VA minus VB positive, negative or 0? So guys, here again we are going to use the formula where V is equal to KQ by R, where V is inversely proportional to R. Okay, inversely proportional to R. Hence, whenever V increases, R decreases, or V decreases whenever R increases. That's how their relation is connected. So if we are going to take this VA minus VB, they are going to be greater than 0. Greater than 0. Okay. And hence VA is greater than VB. Therefore, the charge is going to be positive. Okay. Moving on to the video, you can find some more questions based on this chapter. So I hope you understood. Thanks for watching.